Hi everybody, my name is Carston. I'm from Honeycomb Maps, and I'm really excited to talk about creating internal geospatial tools that people will love to use. I'm going to start with a story. I moved to Berlin about 3 years ago to work at a cool mobility startup here, and one of the first projects I worked on was building an internal geospatial tool. And I thought this was so cool. We were gonna get data from Snowflake, bring it into this internal web UI, and for the first time, everybody could see our vehicles on a map. So I made this tool and nobody used it. People even went as far as saying, yeah, that's a nice map you made, Carston, but could you add a button so I could download the data to Excel? And if anybody has built data products before, you know this is just a knife to the heart. You put all the work in, and they just want to download it. So I started thinking, what did I do wrong? Because there were some tools that people seem to use a lot. Things like Google Sheets. Even mapping tools like Kepler or Google My Maps. So it clearly wasn't an issue with people not wanting to use technology, not wanting to use web apps. It was something I was doing wrong. So I tried to think about what the tools people like to use all had in common. And I put together a little list. First of all, they were all web-based and really easy to get into. No need to sign up, and nothing to install. Second, they employed this UI technique called direct manipulation, which is where if you want to move something, you just move it. Then there's no geospatial background required. We had people from finance teams, operations teams. They couldn't tell you what GIS was or why it mattered, but they didn't need to. They really did great with these tools. So let's talk a little more about human-computer interaction and this idea of direct manipulation. All of you have probably used it hundreds of times today. Direct manipulation is when a user's action immediately causes a result on the screen. The basic example a lot of people use is pinch to zoom on the iPhone. As you're zooming, you get immediate feedback on how far you've zoomed in and when you want to stop zooming. And this is contrasted with something like a command language, where you're writing, using some sort of language to describe what you want to do. And I think you can understand which one is easier for people to use and is the dominant human interaction form today. Now, to make this direct manipulation trick work, you need to be providing real-time feedback to the user. I'm sure everybody has the experience of something freezing, becoming glitchy, and suddenly this experience of being in control falls apart, and you're suddenly frustrated instead. So the best practice here is to give feedback to your user within 100 milliseconds, so 1/10 of a second. Now let's talk a little bit about systems design. I've got this great 1990s clip art here to help. And here we have clients and servers. Both clients and servers are just computers. Client is typically the computer that's sitting in front of you, and the server is sitting at a distance. So the client could be your phone, could be a laptop, it could be an Apple Vision headset, and then your server would be something either maybe on a server rack in a closet, could be in a data center somewhere in the cloud. And when you're architecting an application, it's important to think about who does what. You could have a thick client where the client is doing most of the work, or you could have a thin client and then a thick server where the client is just passing along the inputs from the user to the server, and then the server is responding and the client is showing that to the user. And this isn't black and white, this really exists on a spectrum. But we can start to think about how various geospatial applications fall onto the spectrum. So tools like ArcGIS or QGIS are programs that run locally on the client side. Then maybe some different tools like Foursquare Studio or Carto run in the browser and have a pretty significant server-side component that is responding to user feedback. But let's remember, for this direct manipulation experience that people really like to work, we need to respond within 100 milliseconds. That means if you have a thin client, thick server, you only have 100 milliseconds to complete this loop. And there's a lot of reasons that's difficult. For example, if I have a server here in Berlin and I have a user in New York, it takes about 90 milliseconds just to send that data to New York and back. So that only leaves me with like 10 milliseconds to do all my computation. So that's tricky. So what was that other architecture again? This would be having a thick client that is doing most of the work, and the server is just initializing, sending along the program to start. So to go back to what all these tools people liked had in common, they were web-based, they had this UI around direct manipulation, and they didn't require a geospatial background. So it was pretty clear I wanted to build something in the browser. And so you have HTML for content and layout, CSS for appearance, and then JavaScript for interactivity. And today I want to talk about another emerging web standard called WebAssembly, or WASM, that provides code execution in the browser. So what WebAssembly does is lets you take many different languages, run them in the browser very quickly, and this opens up a ton of opportunities for client-side applications that otherwise wouldn't have been very possible. Because, as I'm sure all of you know, most of the geospatial code in the world is not written in JavaScript. Turf, though, is great. But with WebAssembly, geospatial applications are no longer tied to this client-server model. I strongly believe that this enables a new generation of powerful, intuitive, and accessible geospatial tools. And WebAssembly isn't some brand new standard. It's been adopted by all 4 major browser engines since 2017. And it's even used by this small geospatial firm out in California to power their client-side projection engine. They rolled this out back in 2018. So it's used very broadly and very well supported by this point. And so I built the application that I wanted at my last role. It's called Honeycomb Maps, and it is interactive maps for optimal operations. It's web-based, it has a direct manipulation UI, and there's no geospatial background required to use it. So Honeycomb is built specifically for logistics and last mile delivery companies. Operations managers can pull up the tool, see a heat map of where deliveries will occur, and then they can tweak delivery zones. And as they drag the polygons for the delivery zones, they're getting real-time feedback on the number of parcels and the total amount of weight in those zones. Then once they've optimized these zones, they can save them back to their operational systems. And because we're using this thick client architecture that WebAssembly enables, there's a lot of benefits that set Honeycomb apart from other tools. First of all, there's near instant responsiveness, where the goal is 100 milliseconds. We're able to return most input in 40 milliseconds. Customer data never touches our servers because the application runs completely on the client side. So it's a GDPR compliance team's dream. And then finally, server costs don't scale with usage. So we really want our users to use it as much as possible because from our perspective, it's a flat cost. But this architecture isn't great for all use cases. Because all data and code has to be loaded onto the client, it's not great for things like analyzing satellite imagery, for example. And laptops are really powerful now, but they're not that powerful, and they're not going to compare to something like a compute cluster. And for now, WebAssembly only runs single-threaded. That will probably change this year. So to make things a little bit more real, here's how a large parcel delivery company is using Honeycomb today. Their operations managers can log into an internal website where Honeycomb is embedded into an iframe. So the website loads, then the iframe loads, grabs the application from our CDN. Then Honeycomb itself is requesting data from their S3 bucket using a pre-signed URL. At this point, the operations manager can see a heat map of all of their upcoming deliveries. They can draw delivery areas and then see how many packages and the weight in each area. And then once they've finished creating these different areas, they can save them, and that data is sent back to this company's operational tools to go out and create routes for the next day. So I'm really excited about what WebAssembly and these new client-side technologies mean for democratizing access to geospatial tools that are accessible, elegant, and powerful. I think the question I leave with you is, what will you create with them?